Good morning, dear children. Today we will come to the next portion or the next topic of the same chapter, thermometer, different types of thermometer, and the relation between the Celsius scale, Fahrenheit scale, and Kelvin scale. Now, as you all know that the SI unit of temperature is Kelvin. Though the SI unit, the System International Unit of temperature is Kelvin, but the other units can also be used, that is degree Celsius and degree Fahrenheit. And we commonly use this unit rather than the Kelvin scale of temperature. Okay. Now, we can measure the temperature of a body by using thermometer. Or thermometer is an instrument to measure the temperature. So one of the thermometer is a clinical thermometer. So this clinical thermometer, these are used by the doctors to measure the temperature of human body. And this thermometer are mapped in two scales here. One is a Celsius scale, other one is a Fahrenheit scale. So in a Celsius scale, the normal temperature of human body is 37 degrees Celsius, or approximately 37, that is 36.9, or we can consider as 37 degrees Celsius. Whereas in a Fahrenheit scale, the normal temperature of a human body is 98.4 degree Fahrenheit. So if it crosses or if it goes beyond that temperature in both in a Celsius as well as in a Fahrenheit scale, then we suffer from fever. Okay, so these are about the clinical thermometer. Now let us come to the types of thermometer. Different types of thermometers are there. And the two types we discussed, one is the mercury thermometer, other one is the alcohol thermometer. Now this mercury thermometer, in a mercury thermometer, mercury is used as a thermometric liquid, or a liquid which is used in thermometer is a mercury. Now why mercury is used? It has got advantages, okay, as well as it has got some disadvantages also, okay. Now let us come to the mercury thermometer first. Now this mercury thermometer, now this is the diagram of a thermometer. Now this thermometer consists of a glass tube, or we call it as a glass stem. Okay, and inside the glass stem, it consists of a very thin tube, a very thin glass tube known as the capillary tube. Okay, and this portion we call it as a glass bulb. This is known as the glass bulb. This is the bulb of a thermometer. And inside there is a capillary tube, outside there is a glass tube, okay, and within this, and the mercury is filled in the glass bulb. Okay, mercury is, this is the mercury which has been filled in, okay, and the mercury, it rises up, and there is a mark given with it, which we call it as a graduation mark, and this mark is given in Celsius as well as in the Fahrenheit scale. These are the scales which has been given, mark which has been given here, okay. And it is filled with the mercury. And once the mercury, it rises up, okay, it gives the reading in the thermometer. But once the mercury rises, the mercury does not come back, it does not fall. Because there is one structure which is present near the glass bulb. Near the glass bulb there is one structure, and that structure is a bent structure is there, some sort of bent tube is there, which we call it as a king, K-I-N-K, king, or also known as the constriction, C-O-N-S-T-R-I-C-T-I-O-N, constriction we call it, or we call it as a king. Now this king, which is present near this glass bulb, okay, and this king will prevent the falling back of mercury, okay, into the bulb once the thermometer is taken out from the mouth or from the armpit. That means wherever the mercury has raised, okay, the mercury remains, the mercury doesn't come back. Once you remove the thermometer from your mouth or from the armpit, the mercury doesn't come back. Because there is one structure, okay, which are present near the glass bulb, which we call it as a king. Okay, now this is about the thermometer. Now this, and what happens is that, now when the mercury rises up, okay, and this mercury will rise according to the temperature. If there is a rise in temperature, the level of the mercury, it keeps on rising. Okay, and whatever the level of mercury which has been raised will give the temperature of that particular body or that particular object. Okay, so these are about the mercury thermometer. So mercury is used as a thermometric liquid. Now, why mercury is used as a thermometric liquid is because the mercury has got a very high boiling point. The boiling point of mercury is 357 degrees Celsius and a low freezing point minus 39 degrees Celsius. Okay, 357 degrees Celsius, 57 degrees. This is the boiling point, and minus 39 degrees Celsius is the freezing point of mercury. So it can record a temperature which is a very low temperature, that is minus 39 degrees Celsius, and it can record a very high temperature up to 357 degrees Celsius. Okay, so that is why it can be used as a wide to record a wide range of temperature. And this mercury, it is not opaque. It is shiny, and it can be seen from the glass tube. From outside you can see how much level of mercury has been raised. It does not stick to the glass bulb or to the capillary tube. Okay, it does not form air bubbles. Okay, and it can be formed in a pure state. All these are the advantages of using mercury. Okay, and other disadvantages also there. They expand very slowly, number one. Okay, and the freezing point is minus 39 degrees Celsius, and it cannot record a temperature which is below minus 39 degrees Celsius. So there are some disadvantages of using mercury also. Okay, now next one is the alcohol thermometer. Now this alcohol thermometer are used in the region where the temperature is very low, like in the Arctic region as well as in the Antarctic region where the temperature is very low. Okay, this alcohol thermometer I used here, and alcohol is used as a thermometric liquid here. Instead of mercury, alcohol is used here. Okay, and the alcohol, the freezing point of alcohol is minus 115 degrees Celsius, which is very much less compared to that of mercury. So that is why having a very low freezing point, these are used to record or to find the temperature in a very cold places where the temperature is very low. But their boiling point is only 78 degrees Celsius. Boiling point is only 78 degrees Celsius, which is very much less than the boiling point of mercury. So therefore it cannot record a very high temperature. So that is why this alcohol thermometer are used in a region where the temperature is very low or the temperature is very less. So these are used in a very cold places. So this is about the mercury thermometer and alcohol thermometer. Now let us come to the relation. So before we come to that point, now in a thermometer, okay, there are 2 points, upper fixed point and the lower fixed point. Now when we talk about the Celsius scale, okay, in a Celsius scale, 0 degrees Celsius to 100 degrees Celsius. 0 to 100 degrees Celsius. Okay, now 0 degrees Celsius is the lower fixed point. The 2 points are there. 2 scales, 2 points are there in a thermometer. One is a lower fixed point, other one is a upper fixed point. Lower fixed point is considered as 0 degrees Celsius. And this 0 degrees Celsius is known as the melting point of ice. Lower fixed point is also known as the melting point of ice. And the temperature of the melting point of ice is 0 degrees Celsius. And other one is the 100 degrees Celsius is the steam point or the boiling point. Okay, the boiling point or the steam point we call it as 100 degrees Celsius. So between this 0 degree and 100 degrees Celsius, okay, it is divided into 100 equal parts. That means 10, 20, 30, 40, 50 and so on up to 100 degree. That means it has divided into 100 equal parts. In a Celsius scale, the lower fixed point is 0 degrees Celsius, upper fixed point is 100 degrees Celsius, and between 0 to 100 degrees Celsius it is divided into 100 equal parts. That in case of a Celsius scale. In terms of Fahrenheit scale, the lower fixed point is marked as 32 degrees Celsius, Fahrenheit. The lower fixed point is marked at 32 degrees Fahrenheit, which we call it as ice point in a Fahrenheit scale. Ice point in a Celsius scale 0 degrees Celsius, ice point in a Fahrenheit scale 32 degrees Celsius. 32 degrees Fahrenheit. And the upper fixed point is 212 degrees Fahrenheit. Upper fixed point is 212 degree Fahrenheit. In case of a Fahrenheit scale, This is in case of Fahrenheit scale. And between this 32 and 212 degree Fahrenheit, it is divided into 180 equal parts. In a Fahrenheit scale, it is divided into 180 equal parts. See the difference here. In case of a Celsius scale, and we are coming to the relation between the Celsius and the Fahrenheit scale. Okay. So before we come to the relation, let us understand about the fixed point, the upper and the lower fixed point in both the scales. Okay. Now the lower fixed point in the Fahrenheit scale, 32 degree Fahrenheit, upper fixed point 212 degree Fahrenheit. So between this 32 degree Fahrenheit and 212 degree Fahrenheit, it is divided into 180 equal parts. So following this condition, this relation, okay. Now what I can do is now I can find the relation between the Celsius and the Fahrenheit scale. Okay, now Celsius and the Fahrenheit scale, you know the formula in class 6 also I taught you. That is C upon 5 equals to F minus 32 upon 9. This is the relation. So how that relation has come in? Now let us consider C is the Celsius scale minus, what is the lower fixed point in the Celsius scale? 0 degree Celsius divided by Celsius scale is divided by how many parts? 100 equal parts equals to, I'll write it a Fahrenheit F minus, what is the lowest scale in the Fahrenheit scale? 32 degree Fahrenheit divided by how many parts is divided? 180 equal parts. So 0 cancels here, 2 5s are 10, 2 9s are 18. So what I can write, 0 doesn't have value, so I can write here C upon 5 equals to F minus 32 upon 9. So this is the relation between the Celsius scale and the Fahrenheit scale. So we always mark up this C upon 5 equals to F minus 32 upon 9. But how that relation has come? This relation has come from the upper fixed point and the lower fixed point, both in a Celsius scale as well as in a Fahrenheit scale. Okay? Now from here, from this relation, now how to calculate the temperature in Celsius scale as well as the Fahrenheit scale, will come to that point. Now, see this relation here, C upon 5 equals to F minus 32 upon 9. Now cross multiply here, okay. C into 9 multiplied here, 9C equals to, cross multiplied here, 5, then F minus 32. Okay, then C equals to 5 upon 9 F minus 32. So in order to calculate into Fahrenheit scale, you can use this formula. So degree Celsius equals to 5 upon 9 into F minus 32. So when you are required to convert Celsius Fahrenheit scale into Celsius scale, you use this relation. You can directly use this one also, but you can cross multiply it and you can find it this way also. Okay, so degree Celsius equals to 5 upon 9 into F minus 32. Okay, similarly, this is the first formula to find to convert the Fahrenheit scale into Celsius scale. How to convert Fahrenheit scale into Celsius scale? You can use this formula here. Second one is there. Second one again the same thing you will do. Now you cross multiply from this side. Okay, 5 will do F minus 32 cross multiply equals to 9C. Okay, multiply this. Okay, now what I can do is that F minus 32 equals to 9 upon this side will come down C. Okay, then F equals to 9 upon 5 C. Take this plus minus 32 on the right hand side, that will become plus 32. So this is the next formula. So to convert Celsius scale into Fahrenheit scale, you can use this formula. Degree Fahrenheit equals to 9 upon 5 C plus 32. Degree Celsius equals to 5 upon 9 F minus 32. So these are the two relations. Okay. Now also in the Kelvin scale. So how to convert into the Kelvin scale? To convert into Kelvin scale, temperature in the Kelvin scale, okay, TK, Tekuma, that is TK, temperature in Kelvin scale we call it, equals to degree Celsius plus 273. Okay, so in order to convert temperature in a Kelvin scale, if the temperature in Celsius scale, if you are required to convert into Kelvin scale, simply you add 273. 270. So this is the formula. TK, that is temperature in a Kelvin, equals to degree Celsius plus 273. Okay, so these three formulas you will learn it, you will follow it. Okay, how the relation has come, and this is important when you convert Celsius, and this will helpful in numericals when you solve the numericals. When you convert Celsius into Fahrenheit scale, Fahrenheit into Celsius scale, or Celsius into Kelvin scale. Understood? So this is the relation between the three different scales of temperature. Thank you.